Okay, so this is the video for 11.1 sequences and summation notation. Let's start out by defining what a sequence is. A sequence is a set of numbers written in a specific order. This implies that there's pattern. And so notice that when it's written this way, a sub n denotes the last term. A sub n can also be representing the general term or the formula. So here I tell you to find the first 5 terms and the 100th term. Well, in this specific type of form, there's a lot of different ways to describe this, but it's closed so that you could find any term you wanted. To find the first term, we're just going to plug a 1 in for n. So that's going to give us a 1/2. Sorry, let's see if I can write that a little bit neater. 1/2, there. Then the second term, okay, is going to be where you plug 2 in. And so you get 1/3. And you can kind of see the pattern. You don't have to continue to plug that number in if you can figure out the pattern. Now, to figure out what you're doing in terms of how to come up with the next one, that's easy. But to figure out what you're doing to the previous term to get to the next term, that can be more challenging. And there's another form that's more conducive to that type of thing, and we'll get to that. So although we can't say the pattern is you're doing this each time, we can clearly see what the pattern is, that you're raising 1 on the denominator. All right, so then the 100th term, which we denote by a sub 100, would be 1/101. Okay, now we get to one a little bit more complicated. Notice this top part right here. All this is going to do, if you think about it, is if you plug in an odd number, you are going to get a negative. And if you plug in an even number, it's going to change to positive. Okay, so it's important here to note the first one. Should the first term be positive or negative? Well, that's an odd number, so that's going to be negative. So I do negative 1/2 to the 1 power, which is negative 1/2. Okay, so now we plug in a 2. Okay, so negative 1 squared, that would be positive 1 over 2 squared, which would be 4. So we can see that we're doubling the denominator. So the next term is going to be an 8 or 2 cubed, and it's going to be negative, and there's going to be in every other aspect. So hopefully you're kind of predicting what the next term is, and it said we had to find 5. So again here, all the odd number terms are negative, 1, 3, and 5, and the even number terms were positive. So what do you think a sub 100 should be? Without plugging it in, do you think it should be positive or negative? Okay, well 100 is an even term, so it should be positive. And I'm not going to make you do 2 to the 100 power. We're just going to write it. Okay. So this says, this is a little bit different. They're giving us some terms and they're telling us to find the nth term. This means find the formula. Figure out what the pattern is and write it as a sub n. Now, anytime you're given fractions and you can't immediately see what you're doing to the previous number to get to the next number, just think about, and let me make this first number as a fraction. Just think about how the first number relates to 1, how the second number relates to 2, how the third number relates to 3, and if you notice the denominator is n. How is the numerator related? It's 1 more, so we just write n plus 1, and there's no need to try to simplify or anything. Okay, on this next one we can see that we are multiplying by 2 each time. It's a lot like 1b that we did. There is an aspect of a negative 1. So let's put our negative 1, and it could be going to the n power, or it could be going to the n plus 1. In this case, since the odds are the negative ones, it's just to the n. Well, let's say this had been switched, and this had been positive 2, negative 4, positive 8, negative 16. We would have had to do n plus 1 to account for that. Okay, and we'll talk more about that in class. All right, and then we need to not divide in this case. I know it looks like I left room to divide. That was a mistake. We need to multiply by 2 to the power of n. All right, so this is our answer. There is another way we could have written this. We could use our exponent rules and write this as negative 2 to the power of n. But honestly, neither one of these is really better than the other. Okay. So here we have something called recursive. This is where you take the previous term and you do something with it to get to the new term. Okay, and this right here is the previous term. That's all that means. It's the term before the one you're talking about. You have to be given at least one term in order to do recursive. Normally you're just given the first term, but it really could be first 2 or the third or whatever. All right, and so now what we're going to do is we're going to take this 1, we're going to add 2 to it, and then we're going to multiply that number by 3. So that's going to give us 9. Okay, now we're going to take 9, we're going to add 2, multiply by 3, we get 33. Now we're going to take 33, add 2, multiply by 3, and we get 103. And you should be able to do this without a calculator. And then we're going to take 103, add 2, times 3, we get 315. There is a way to do recursive in your calculator, and I'm going to show you that in class. It's not really important for this lesson. Okay, now notice that I switched up from A to F. There's a reason for that. See if you can figure it out before I tell you. So this time I'm going to go ahead and give you the first 2 numbers, and that's important because I'm giving you the sequences. You're going to add up the 2 previous terms. So it's the previous term and then even the one before that. So in order to get the third term, I have to add up the 2 previous numbers. Okay, so the third term is the first term plus the second term. So that's going to be 2. All right, now to get the next one, I'm going to add 1 and 2 to make 3. And then to get the next one, I'm going to add 2 and 3 to get 5. It's not summation of the whole thing. It's just the 2 previous terms. Now, just to make sure we've got this, what's the next term? I didn't ask us. 8. Now, what do you think this is called? Starts with an F. It's called Fibonacci, and we're going to talk about this more tomorrow because there's a lot of application to the Fibonacci sequence. Okay, so now let's talk about what a series is. A series is a sum of a sequence. It's just adding up the terms. Partial sum is a finite number of terms. Okay, so it says, for example, S sub 5 is called the 5th partial sum, and it's the sum of the first 5 terms of the given sequence. So if you want to add, it's just A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5. So if you can find the first 5 terms and add them up, that's one way to do a sum. Now there are tricks to some of these. All right, so here, there's no trick on this one, but we're just going to find 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. You're going to find those numbers and you're going to add them up. Okay, and I'm not going to spend a lot of time in this video on how to add and square numbers. So 55 is your answer. Okay, on the next one, notice that we're starting at 3. So that's going to be 1/3 plus 1/4 plus 1/5. So there were not 5 total terms, it's just that we stopped at the 5th term. All right, and again, I'm not going to spend a lot of time on how to add fractions, although you would want to get a common denominator here. And your answer is 47/60. Okay, there is a trick to this next one. Okay, every term is 2, so it's 2 plus 2 plus 2. The 4th term is 2, the 5th term is 2, and the 6th term is 2. Do you really need to add all these 2's, or is there a trick? You could have just said 2 times 6, which is 12. Okay. Write each using sigma notation. Okay, so this is asking us to do this. The sigma, we need to write the rule, we need to write the number we start with and the number we end with. So it looks like we're starting with 1. So we can say k equals 1 and it stops at 7. And what is the pattern here? What is the rule? How do you get each term? You're cubing k. Okay, and that's all it's asking us to do. All right, on this next one, you can be complicated or you can be simple, and you guys know me, I like to keep things simple. So since this starts with a 3, I'm going to start with a 3 here. I'm not going to worry about making my rule complicated. I'm just going to start with 3, and that means I'm going to end with 77. So then square root of k is my rule. No worrying about adding 2 or subtracting 2 or what I need to do. Okay, the only thing I want you to do is write these 2 words. Arithmetic and geometric. Now these were 2 specific sequences and series that you learned. Okay, arithmetic is anything linear. This means you're adding some constant, or you could be subtracting each time. Geometric is exponential. This means you're multiplying by a constant, and that also means you could be dividing. Okay, we're going to talk more about this in the next lessons, mainly geometric. Okay, bring your questions to class.